I'm going to talk a little bit. It's going to be a little bit of storytelling, a little bit of references through my own life and my experiences with gaming. So, like, one of the things that, let's see if this thing works. So, once upon a time, I was like a little kid who was like really into games, and the first experience I ever had with gaming was this famous game on Atari called Biplane, which was on a cartridge called Combat. It's not much to look at, but it's actually quite an enticing game because the two of you are basically playing little World War I fighter planes. You're trying to shoot each other out, and if you fly behind the cloud, you can't see the other planes. You don't know where he's coming out. And it's just like the simplicity of the game that kind of like brought me into gaming. But you know, I didn't have an Atari, so what I had was like a good old Commodore 64. And this looks like an awesome classroom. Like, and if you wonder why it's kind of like blurred out, it's because just before I left for Paris, I was going through the slides, and my wife noticed that the 3 blurred out screens were like Commodore 64 sex games. And I was like, uh-oh, this is probably not a good idea. So I had to do a self-censorship a little bit there. But I left like the 80s kind of rock style thing on the left top thing. So this is like an awesome like computer setting for like when you're a kid and you're going to computer class. I had this in computer class. Anybody ever heard of the Hewlett-Packard 150? No, right? Because it sucks. So it's got a touch screen. Look at that, right? The touchscreen resolution of like 2 characters, right? So completely useful. Like whoever would like stand in front of the computer, like touch a screen with their finger, right? I know Microsoft wants us to do it now again with their Surface technology. I don't think it's ever going to happen, and like I challenge them to beat the horribleness of this thing. So then I graduated to the big computer, and I'm an Amiga guy. So if you're an Atari guy, that's all I gotta say. And here's where I kind of like got my first chops on actually coding. You know, like did some assembler, and I was like really like fell in love with this computer because there was like so many parts of it you could explore. You know, you had like a coprocessor, and there was a blitter and everything. And so I decided to like try to learn programming using it. And my first thing I did was like a Pac-Man clone in Blitz Basic, and I wasn't really good because I can't draw for shits, but it worked, right? And so I was like, oh yeah, cool, I can be a game programmer, right? So I had a friend who was like a couple of years older than me, and he just started working at a company called Funcom in Norway. And Funcom is probably more known for like The Longest Journey in Europe and a couple other games. But this was before The Longest Journey, right? And so I went visiting him because, you know, like this is like the coolest place ever if you're a kid, right? Because you're like 14, 15 years old, you go in there, and they have like the new PlayStation, they have like arcade cabinets, everything. And he's like sitting like gray-faced in front of this like PC, like writing like assembly code for a Mega Drive, right? For a golf game. He'd been doing that for like 40 days or something, like 12 hours a day. And I was like, hell no, no, this is wrong. So this is the gaming industry, right? The beatings will continue until morale improves. So I was like, they say like, hey, you interested in that job? I was like, no. Right? It's like, it might be a little bit better now, like if you're all mobile game developers or whatever, and you're doing your indie games, and there's like hope for like you being able to make a living. But eventually I think that the big studios will come in, and it's going to go back to the beatings. So the original Pac-Man is probably considered like one of the best ever 80s games, right? And it's just awesome, like the color and everything. It's 1980, right? We're talking way, way back. I'm old. So here's like my version of it 32 years later. And notice the glamorous graphics and the high fidelity of colors, right? It sucks. And it's not even my graphics, because I couldn't even draw this. I tried, and then I used somebody else's graphics. So I think I'm pretty sure I won't be sued, right? Because there's no way like Namco can look at this and go like, yeah, you copied our game. Well, they could probably sue me for damages for like making their game look so bad, I guess, but. So I'm just going to go on a tiny little rant about like what the state of technology is on game development for browsers. So if you go through like simple timeline on graphics, if you got the 70s, you got like this horrible blocky graphics of the Atari. And this is probably what I can do. Like, this is my skill of drawing. Anybody know what the first game here is?
E.T.
E.T., right? Yeah. The most famous flopped game in history, right? Here's Atari. They basically have the market for themselves. They decide, let's do a movie license, right? Let's team up with Spielberg. Let's pay for E.T. They do, and it's like everybody will want to play E.T., right? Every kid will want to. So let's just get this random dude here. You got a month. Write the game. We don't care what it is. We'll just put it on a cartridge and sell it, right? This is probably the worst game ever made, right? Or it's like you need to indulge in some heavy drinking before you play a game. And if anybody can ever explain to me why E.T. kind of flies up when his neck extends, I'd be really happy to get enough theories around there. It ended up with like millions of cartridges that nobody wanted because even the kids that day wasn't dumb enough to buy into this, right? And the legend has it got buried somewhere out in the desert of New Mexico, right? So there's somewhere in New Mexico in the US, there's a huge mound full of cartridges. So that's the 70s for you. Then after the collapse, you got into the glorious 80s. You know, we get Nintendo. We got the explosion of like different home computers, like the Spectrum, Amstrad, the Thomson. I know in France there was like a computer called the Thomson. And this is like where I grew up, right? This is like where I matured as a kid and where I play games. And I think it's like probably the golden era of computer games. Because like just like you can now with a single computer, you can actually build your own game in the garage, right? And the whole industry here was grown up around people like us working at home, writing their own games. We moved to the 90s, we get the famous Doom. The graphics are getting better. Like we get the first 3D accelerators, and it's just the fidelity is increasing. You get network games, and like first time I saw network games for Doom, I was like blown away, right? So here's like playing with 4 friends. You had to pull all this like cable around the house with your friends, and you had to get them all in the same room to do it, but it was like feasible to play multiplayer. Now 2000s, we're starting to get like, you know, all these massive graphics cards, Skyrim, Far Cry. I mean, the graphics are getting close to real life. And the next 10 years is just going to be amazing, right? It's going to be all this like incredible pixel, perfect graphics that look like movies, right? 10 years, the crappiest PC you have is going to be able to output about this stuff, right? So, HTML5. It's sad to say, but I think the Amiga beats the shit out of this, to be honest. And I know this is like a product of standardization. That's what we're looking at here, right? This is Canvas, right? I know you're going to say, you know, WebGL is out there, right? You can write fantastic like applications of WebGL. Yeah, but forget about running it on Windows, right? Can't do it. Right? It's not a standard. It's not part of HTML5. It's an addition. Native clients, there's some really impressive demos out there. Again, not a standard, just Google. I mean, it's not even Firefox or Opera, so it's just incredibly small. And Flash, Steve Jobs said it's dead. I'm starting to believe him. So unfortunately, it's probably the only client out there. If you want to really write cross-platform 3D games right now, you probably have to target them with Flash using the Unreal Engine or something like that. But I think it's just going to die. So WebGL is rejected. Native clients and Flash, all of them rejected for like a game that can work across all browsers. So you're left with the Canvas, the 16-bit computer screen, kind of crappier actually than the typical 16-bit computer screen, but it works. I won't even tell you about the horrors of sound, of course, because sound is another adventure, and it's just, I mean, I think my Commodore 64 had better sound support than a modern browser. So, taking this into consideration, I decided, like, look, what if I can indulge in like the secret passion that of being a game programmer that I kind of dropped out of when I realized like how horrible the working conditions were. So I said, like, okay, let's build, you know, something I call Mongo Man, like for when I was working in Tangent. It's like, let's take Pac-Man and make it multiplayer, right? let's use Node.js and whatever other tooling we need to like make a multiplayer Pac-Man. So the first thing I looked was a framework, and I found one called Akibara by Francesco Cotone, who is an Italian living in Spain, in Madrid, who has made like a framework which is like perfectly suited for retro games. So it basically covers things like object collision, which is like a typical thing. You need to know when Pac-Man hits the ghost. It has a generic game cycle where you can set up events, you know, like the game started, the ghost got eaten, the Pac-Man, you know, like ate a power pill. It allows you, it handles all the keyboard controls. It even has like touch controls and stuff like that for iPhone and iPad. And there's like, most importantly, there's great examples so that you can actually just start hacking from a game that's already been made, right? And I used their like game called Capman as a template, and then like ripped all the individual logic out, and then like rewrote the logic and connected it to a backend. And as a backend, we went Node.js and WebSockets. And then it's really simple. Like on the client side, you got Akibara, and then I use SoundJS. Like Akibara has sound support, but SoundJS is definitely the more stable one. If you need to use one across all different browsers, it kind of automatically figures out how best to do it on Firefox versus Chrome and that kind of stuff. And on the server, there's like Node.js, there's ExpressJS and WebSockets, and just using MongoDB as a giant ring buffer, which I'm going to touch up in a second. So a ring buffer, in this sense, is basically just a giant first in, first out queue. So the reason I'm using that is like I want to keep the state of the games. All right? So when there's a game with 3 players and you're a new player, you want to like be able to find a game that's currently in play. So you go and look in some data structure, right? And so I'm using MongoDB basically just to keep this in a giant ring. So when it finishes, when it writes at the end of the ring, it overwrites from the start again. So I can keep everything in memory, and it works fast. Each game lives in one process. So Node.js can have like multiple processes connected to a socket. To make it very simple so that you don't have to talk from one process to the other, when you're playing as a gamer, you're basically tied to one game that lives in one process. So depending on which process you're connecting to, you will get a game that is in progress in that particular process. And this reduces the amount of like communication you have to do between the processes. And then like here's like the big thing, right? So we've all heard about like TCP, right? And we know all about WebSockets. I'm here to tell you that like it's not all cracked, all it's cracked out to be. Like WebSockets is not really good for games like Pac-Man. And the reason why is that it's based on TCP. So TCP basically takes your messages and sends them in order, right? So if you send message 1, 2, and 3, it needs to be received in the order 1, 2, and 3 on the other side. But if message 2 disappears in the internet somewhere, it stops and waits for another message to another copy of number 2 to arrive. That means that when you're sending lots of information to the browser, like where Pac-Man is moving in the maze, if one message is missing, it just stops up, right? And you have to wait until the new message comes. And this leads to a situation where your Pac-Man might be jumping, you know, like because it doesn't get all the messages. Solution, what all gamers have done for always, forever, when it comes to network, is UDP, right? So UDP basically is the same, but it has no ordering. So if you get the message, you got the message. If you didn't, well, you didn't know about it. So this is good, because even if you lose like 4 messages out of 100 in 1 second, it doesn't really matter, because there's other 96 messages got there, right? And for a game where the character moved in 1/100th of a second doesn't really matter. There's a good solution to this, though, if it ever gets ratified, because we know how that is. WebRTC. So WebRTC is like built for making your Skype in the browser kind of thing. But part of it is called a data channel. Now, that isn't specified. It hasn't been approved. There's like some hacky version of it in Google Chrome, I think, in the Canary builds. But basically what it does is that it introduces peer-to-peer connections between browsers. And it also introduces a thing called the Stream Control Transmission Protocol. Now, that's catchy, right? SCTP. which lets you basically decide if you want to send ordered or non-ordered messages. So this means that you can now build a game like Mongo Man and ensure that the speed of the characters is good because you can now connect the browsers directly to each other. So your server is just acting as the negotiator of where the game goes. Another thing that's important is locality. So if you play a game like World of Warcraft, you're never actually logging on to World of Warcraft in the US, right? You're always going to log on to the server in France or something like that. And that's because the amount of time it takes for a message to go to that server and come back means that you're going to get these jumps in like your character. Like basically, you're not getting enough information to make a live flowing game, right? So this is the problem of latency. And to give you 2 examples, like if you have a 20 milliseconds ping time to a server, that means like at the worst time, it takes a message 40 milliseconds to get to you. So when player number 1 moves, he sends the message to the server, and then the server goes to player number 2. That means that the resolution is 25 frames per second. All right? That's pretty close to full motion, right? And plenty for a game. If you have 135 milliseconds, that becomes a 270 millisecond return trip and 4 frames per second. So you can already tell that's pretty bad. Then there's a couple of Node.js things you need to make sure and that you understand. Like one of the things is like, since Node.js lives in processes, the memory you have is the memory you use. So if you're sitting around and storing a lot of objects in memory, your memory is going to increase, right? So you have to make sure that like your code is as lean as possible, ensure that the memory usage is as conservative as possible, because once you start hitting like high-level memory usage, the V8 garbage collector is going to aggressively kick in, and you're going to stop your game as well. And then like, we know we're all into cloud and everything like that, but the reality is like if you're making real-time games, you should consider dedicated hardware because you have a guarantee for how much performance is and that it's consistent. So if you build your game and you put your server on Amazon, there is a risk that at that given point in time, there is a flick in like performance because something else starts up or some I/O is unavailable or something like that. So you might have to consider dedicated hardware. If you, of course, like build a game like Zynga, it doesn't matter, right? But if you want to do a real-time 3D shooter, dedicated hardware. And then, like in Node, the event loop latency is like crucial, right? Do as little as possible from the point that the request enters to you actually send something back. That means you can have higher concurrency. So the less you do in an event loop, the more event loops, the more requests you can actually handle in an event loop.